The problem states, find the magnitude of the induced current on 20 turns of wire with internal resistance 5 ohms if the time-varying magnetic field through the loop is B field equals 2x hat minus z hat sine 40t. Use Lenz's law to figure the directions of current. Is it positive or negative for small t according to the direction drawn in the figure? Okay, so first thing we're going to do is calculate the magnetic flux. The magnetic flux is the product of the average magnetic field times the perpendicular area that it penetrates. So the B field is defined as this. The direction 2x hat is going this way. And that's not perpendicular to the area, it's parallel to the area. So, however, negative z hat, that is going into the board, and that's exactly perpendicular to area. So we ignore 2x hat, and we only consider negative z hat as the direction of our B field. So, we don't take that into account writing magnetic flux, we're just going to be writing sine 40t. And then our area would just be length times width, which is 40 centimeters times 4 centimeters times 3 centimeters. We have to convert that to meters, so we get 0.04 times 0.03. And that would just be sine 40t 0.0012. I'm just going to rearrange that, and that is our answer for the magnetic flux. Now we are going to find the V Emf. So the V Emf, so Faraday's law states that the EMF is given by the rate of change of magnetic flux. So then we write negative, which denotes from Lenz's law, and then N is the number of turns of our the wire, and then the time derivative of the magnetic flux. And then this would just be negative 20 multiplied by 0.0012, they're both constants. And then the time derivative of the magnetic flux. Okay, so sine 40t is time varying. So we take the derivative of that. So derivative of sine is cosine, and sine 40t would just be 40 cosine 40t. So the time derivative of sine 40t is 40 cosine 40t. And then just multiplying this out, we're going to get negative 0.96 cosine 40t. 0.96. Let me circle this answer. Okay, now we're going to find the induced current. So the induced current, to calculate the induced current, that's equal to just the V Emf divided by the resistance. So our V Emf is just negative 0.96 cosine 40t over 5. And then we get our answer to be negative 0.192 cosine 40t as our answer. for the induced current. Now we're going to use Lenz's law to figure out the direction of the current, if it's positive or negative for small t according to the direction drawn. So when time is equal to 0, B is increasing in the negative z direction, going into the board. We know it's increasing because so our B field is sine 40t. The derivative of sine 40t is cosine. When cosine is equal to 0, so let me write this out. So when at t equals 0, cosine of 0 is equal to 1. So that means it's changing faster. And so if it's changing faster, that means it's increasing. So when time is equal to 0, B is increasing in the negative z direction. We want to bring a balance to the system, so we oppose that. So then, opposing that, the B field would be coming out of the board, the induced B field would be coming out of the board, and then the induced current would be going in a counterclockwise direction. So I induced would be in a counterclockwise direction. So if it's going in a counterclockwise direction, that means the sign is going to be negative according to Lenz's law. And that is it for this question.